This is CPM Calculus, Chapter 3, number 178. Find the end behavior function for the following functions. Okay, so be careful. We're not just looking for the end behavior. We're looking for the end behavior function. All right, so A, we're given f of x is equal to 2x squared minus 3x plus 1 over x plus 2. We know that the limit as x approaches infinity, right, is basically we're going to be looking at the biggest power of x in the numerator and the biggest in the denominator. And this one is going to be much bigger than the one in the denominator, so it's going to approach infinity. Yes. But what is the function that it's going to approach? Well, this one, let's go ahead and look at it. We want to go ahead, let's divide x plus 2 into our numerator. Okay, so let's do that in long division so we can get actually expressions plus a rational expression. Okay, so let's go ahead and do this. 2x squared minus 3x plus 1. So when we divide this, what do we have? First of all, we always look at the first terms. 2x squared divided by x is just 2x, right? So then we multiply this over. This is just long division with polynomials. This is going to be 2x squared plus 4x, right? And we want to subtract this. That subtraction gets distributed, so it goes both these terms, right? 2x squared minus 2x squared is 0. Negative 3x plus negative 4x is negative 7x. Bring down the 1. All right? So again, we do this. X plus 2 into negative 7x plus 1. Well, we look at the first terms. That's going to make it minus 7, right? So then we go ahead and multiply that negative 7. That's going to be negative 7x minus 14, right? We're subtracting this. When we subtract, this distributes. So this becomes positive, positive, positive. Negative 7x plus 7x is 0. 1 plus 14 is 15. Okay, so we no longer have x's, so then this just becomes plus 15, right? That's the remainder over, and then we now have over x plus 2, right? Because we were dividing it by x plus 2. So we have this is equal to this. So let's go ahead and write that out. This was the work on the side. So this is f of x is equal to 2x minus 7 plus 15 over x plus 2, right? Well, as x gets bigger and bigger and bigger, what happens to this? We see that 15 over x plus 2 now is basically going to be 15 over a really big number, right? So let's go ahead and say it as x approaches infinity, right? F of x, what happens to f of x? F of x approaches, right? This becomes 0. This is going to be, we can still say 2x minus 7. We know this is going to be like infinity, right? Infinity minus 7. Plus, what is this? Well, this gets thrown in the trash, plus 0. Okay? So the function we know is not going to be paying attention to this at all, right? Because it becomes 0. So the end behavior function is just going to be 2x minus 7. So end behavior is 2x minus 7. All right? Because it's basically going to look like the line 2x minus 7 as x approaches infinity. And negative infinity, right? We can even say as x approaches negative infinity, let me make negative infinity better, f of x is going to approach 2x minus 7 plus, again, if we have negative infinity, well, 15 divided by negative infinity is still 0. So this is still the end behavior function. All right? So let's go ahead and move on to part B. Part B, we're given g of x is equal to 1 over x plus sine of x. Well, again, we're not looking for the end behavior because we know what happens if we plug in like infinity and negative infinity. We want the end behavior function, Okay, so what is that going to look like? Well, we kind of do the same thing. As x approaches infinity, then what happens to g of x? G of x approaches, well, 1 divided by infinity we know is 0, plus, well, sine of x we know is just oscillating forever and ever and ever. It's a periodic function, right? So this one stays sine of x, right? It's still going to be going up and down wherever it is. Okay? Likewise, as x approaches negative infinity, g of x approaches, well, if you plug in negative infinity here, it's still going to be 0. And sine of x, again, goes up and down, no matter where it's at. Okay? So the end behavior function then, right? The end behavior function is just 0 plus sine of x, which is sine of x. All right. Let's go on to part C. Part C, we have h of x is equal to sine of x over x. All right. So this one, we're going to look at the same way. As h of x, as x approaches infinity, what happens to h of x? Well, h of x approaches, well, we know we're going to have this oscillating function in the numerator and a really, really big number in the denominator. Well, that oscillating function is it oscillates between -1 and +1. So that's pretty much a constant number oscillating up and down as the denominator gets really, really, really big. So that's basically some constant, well, let's not even write constant, let's say oscillating, oscillating, oscillating number over a really big number, right? And so that's basically going to become 0. Okay, because we're saying, well, if we plug in x is infinity, well, this is still going up and down in the numerator, and in the denominator it's so big, so that ratio is going to be 0. So the function, you can even say, like, the function is basically going to have, going to be approaching the x-axis, and it's basically going to be approaching 0. And so the function, behavior function, is actually 0. It's not, so the behavior function, you can even say, is y equals to 0, right? Is the end behavior function. Just like in part B, it should be y is equal to sine of x because it's a function, so we want to name it. And part A, again, we could say y is equal to 2x minus 7. All right, so that ends CPM Calculus Chapter 3, number 178.